Hello and welcome to Chapter 6. Now we're going to talk about strings. This is really the last chapter that I'm just going to ask you to please learn something without exactly knowing how to do it. We're just sort of chopping food. It's like you're going to be a chef eventually, but we're just chopping food. So Chapter 6 is the last chapter that you just have to learn how to chop food. We're going to actually make a meal in Chapter 7. Once we have a file, then all of the things that we've learned how to do are going to come into play. So just trust me and listen for one more chapter. So we literally have been using strings from the very first moment because the first thing we did is print hello world. And so, this is a slide from a couple of lectures ago. And so, we take two strings, double quotes, single quotes. We use the plus. Remember, it looks to the left, looks to the right. Concatenates. Remember that it doesn't put a space there. Yeah, here's a string that has digits. And now we're going to try to add one to it, and it blows up. Yay. It's hardly even, you're not even sad when you see traceback by now, hopefully. You're just like, oh, traceback's a normal thing. I'm trying to learn it. Type error. Can it concatenate strings and integer? It's trying to tell you what's going on. And we're all good. We then take the string, we pass it into the int function, and then that comes back with 123, and we add that and it becomes 124. So it's all good, right? It's all good. And we've been doing that for a while. Another thing we've been doing is reading data from input. The input function prints out a prompt. That's the prompt. We type something, and then whatever that is comes back as the result of the function, and then it gets stuck into name. And so if we print that, print of course is also a function. We pass name in, we get out Chuck. Even if we enter some numbers like 100, right? That doesn't make Apple a integer. Apple is a string. Input gives us back a string. Input gives us back a string. So we can't subtract 10 from it. Trace back again. But if we can convert it to an integer and then subtract 10, then we can get that 100 minus 10 becomes 90. So we've been manipulating strings and using internal functions and converting them to floats and doing this, that, and the other thing as we have gone forward. But now we're going to start tearing apart strings. So the ultimate thing we're going to do is read through a bunch of data, tear that data apart, read line by line, and then look at each line and find things in the line. So we need to know that a line of characters, many characters, which turns into be a string, a multi-character string, has indexable data within it. So the string banana, and I didn't come up with banana. Actually, the book that I use is based on a book by two people, Alan Downey and Jeff Elkner, and one of those two came up with banana. I would never have come up with banana because I don't know how to spell banana, and I'm terrified of having a slide or the book with a mistyped banana because I just think somewhere in banana there's supposed to be two N's. And I read this and it looks like a misspelling to me, but I'm pretty sure that it's right. But that's neither here nor there. We have this string banana, which is 6 characters, and we stick it in fruit. And if we look in fruit, you can actually pull each character out. We call this the index operator. And the square brackets are the index operator. And I pronounce this sub, so that's fruit sub 1. Now, as we look at the index, the first one is 0. Now that's counterintuitive. It goes right back to elevators that in Europe that have 0 as the first floor, right? 0 is the first floor. So Python was invented in the Netherlands, and that's Europe, and so that all elevators are 0. So the first thing is 0. That's not the reason at all. The reason has to do with performance in computer science, where 0 is easier to add than subtracting 1. But whatever. Just remember, the first thing, the second thing, the third thing, fourth thing is sub-0. So this is a 6-character string, but the last position is position 5. You'll get it. It won't take you long. It'll seem natural pretty soon. Right now it seems unnatural. So fruit sub 1, that means the character in position 1. So A ends up in letter, and so we indeed can verify that. This thing inside of the brackets can be an expression. It can be a variable. It can be anything you want. There's a constant. Here's an expression. X is 3. X minus 1, that becomes 2. So fruit sub 2 comes down here to X, and we see the N that comes out of that. So that's the index operator. We pronounce it as sub, fruit sub X minus 1 is how I pronounce that last little bit. And so it wouldn't be Python if we didn't have a traceback. And in this one, I'm making a mistake. And that mistake is I'm going beyond ABC, which is 0, 1, and 2. And so Zot sub 5 No, sorry, Python is angry at us. Python is angry at us, and so we get an index error. Index error, string out of range. Oh, well, I mean, string index. Well, this is the string, that's the index. That's the, we're doing an index operator, a lookup operator, or a sub operator. So that's just a thing you're not supposed to do. After a while, you kind of get used to the idea that Python is just going to trace back on you from time to time. There is a number of functions. We can pass a string into the len function, and we can get the length. The length of this is 6 characters. It is indeed 6 characters. Even though it's 0 through 5, it's still 6 characters. So the len is just another function. We talked about functions before. Functions take as input some parameter. So fruit is assigned into banana. And then we're doing this. Remember, we evaluate the right-hand side here. This fruit gets passed into len. So the string banana is passed into the len function. The len function does something in the middle of it. And then the len returns us a 6 with a return statement. And then that 6 goes, that's an integer 6, goes to x. So then we print it out and we get the 6. Okay, so len is a function, takes input parameter, and away we go. And so inside of len, there is some code that takes this. It's got a for loop, or who knows what's in here, and then it's got a return statement, and then it returns the stuff, which then replaces this as the residual value in the expression, and then the assignment statement finishes, and then 6 ends up in x, and away we go. So there's lots of things that you can do with strings. Asking how long they are is one of the things that you can do with a string. Now, we want to loop through a string. Well, given that we can have this index operator, sub, we can then generate a sequence of numbers, 0, 1, 2, 3, 4, 5, and then we can look up all of the things, right? And so to do that, we got fruit, banana, and then index. This is our iteration variable. And we're going to construct a loop where we're going to add 1. We're going to increment index by 1. And then we're going to say while index is less than len of fruit, and that's 6, not 5. And this will give us the numbers 0 through 5. So this loop will run with index being 0 through 5. So the first time through it's 0, the second time through it's a 1, then a 2, and then we're going to take the sub-0 letter, and stick it in the string letter. Sorry, letter is a bad choice of a variable. This could be x as long as this were x. It doesn't matter. It's just letter is a reasonably mnemonic variable unless you're trying to give a lecture. See, letter is letter. The letter gets assigned into letter. So if I just said x, x, then I would say it looks up the letter at the position 0 and then puts that letter into the variable x, and then we print out the variable x. Sometimes mnemonic, but there you go. So this is going to run 6 times, 0, 1, 2, 3, 4, 5, 6, and each time it's going to print out the index and the letter that happens to be in that string at the index. So now we've got a loop that goes through each of the letters in a string. Now, that was the indeterminate loop. We had to construct it. We had to make our own iteration variable, etc., etc., etc. But a much more convenient way, unless you actually need to know the position, just if you want to go through all the letters in a loop, a much more convenient thing to do is just use a for, a determinate loop, right? So we're going to use for and in, and remember in is like, member of for all the letters in the set fruit, but in this case it's for the iteration variable letter taking on all the successive values of the characters of fruit. So letter is going to be B, then A, then N, then A, then N, then A. And that means it's going to run this loop 6 times, and each time through, letter is going to be something different. And so it just prints this out. And we didn't have to construct any of that index stuff or any of the fancy stuff. We just rock and roll our way right through that. Here's those 2 loops that I just showed you. Right, here's the determinant loop with the for and the in, and it's nice and clean, and they produce it. Here we construct index, have a while loop, use len, add 1 to index, pull the letter out, and so this line is the same as that line. So this is kind of like 5 lines of code or 4 lines of code, and this is like 2 lines of code. And this might not seem like much, but there's so many places that you can make a mistake here. If this is like index plus 2 or something, Now you do have more flexibility when you're constructing it this way, and sometimes you do have to construct it, but if to do the exact same thing, these two things are doing the exact same thing. And so it's always better to use a more succinct and direct way of describing your code rather than this is like showing off how good you are with the while loop, but it's sort of unnecessary. So use the simplest bit of code that you can use to accomplish what you want. It's easier for you to write, it's easier for you to debug, and it's easier for someone else to understand as they're reading your code. So we can go back to the iteration chapter and think of all the things that we did, whether it was look for the largest, look for the smallest, see if something's there. What this is going to do is this is a simple loop that's going to go through and see how many A's are in a word. Now we happen to know by looking at it, but it gives you this sense of iteration. So we take the letter's going to take on B, A, N, A, N, N, A, and it's going to run this code 6 times. And if the letter is an A, we do count equals count plus 1. We set it to 0 at the beginning. Remember how these loops do something at the beginning, they do something in the middle, and then they have kind of like the payoff at the very end. And so this just means every time the letter's A, we're going to add 1 to count. So this effectively is counting the number of A's in the word banana. And out comes 3, because there are 3 A's. Now if I misspelled it, there would be more N's and more A's, but luckily on this slide I think it's spelled correctly. Now I love this in, and we're going to use this to do a lot of things when we deal with files, when we deal with lists. This idea that in is kind of like this membership notion in algebra. Not that you have to know algebra, but if you do know algebra, it's like for X such that it's a member of this set. That's the concept of in. It's a very clean abstraction. Maybe you'll actually learn Python and then you'll go back and learn algebra and go like, oh yeah, this little member guy, that's kind of like an in statement in for. It's a very abstract concept that really says this is how we're supposed to just run this loop, run this loop 6 times, 1, 2, 3, 4, 5, 6. Do it. Take care of all of the small details for me. Right? And this, again, for me, is the magic of the for loop. It's the Python for loop. Is the for itself, the for loop does a couple of things. It decides how long the loop's going to run, when the loop starts, when the loop stops, and it advances the iteration variable automatically. So it decides, am I done? Go get the next letter, run it. Am I done? No, go get the next letter. Go get the next letter, go get the next letter, go get the next letter. Oh, and now I'm done and I'm going to quit, right? And so the for takes all of this, all that logic is in one statement. And like I said, the less code that you have to write, the better off that you are. Now I showed you how to loop through strings. I'm going to show you ways that you don't have to loop through strings. And so one of the things you do in strings is you basically want to grab a piece of the string. And so this is what we call slicing. And we're going to use the same square bracket to do slicing, except that we're going to put an expression in that tells us how far to go. So here we have a string, 0 through 11. Remember, they start at 0. And so in here, instead of saying s sub 0, which would be the first character, we say s sub 0 colon 4. And so this gives us a range. Now, the key thing here is the end is up to but not including. Okay, up to but not including. So when we say 0, start at 0 and go up to but don't include 4, that says up to but don't include 4. So we don't include 4. Now that again may seem counterintuitive, kind of like 0 starting is counterintuitive, but in a bit you'll see that there are times when it sort of makes sense to do up to but not including. So for now, just remember up to but not including. So if we go 6 to 7, well, 6 starts here, and then up to but not including doesn't include the 7, so that's why we get a capital P. And then if we do 6 through 20, 6 starting at 6, going up through, you'd think this would be a traceback. But it's not a traceback. It is okay. After a while, you're like, I'm a little disappointed in you, Python. You're supposed to trace back every time I make a mistake. Well, somebody decided it was okay to reference beyond the end of a string, and we'll forgive you. It's not going to get anything. It's actually going to stop there, and that's why we get Python as the answer here. Now, Given that the beginning and the end of the string are a very common thing, you want you want a prefix or a suffix off of this string. It's really common to either eliminate the first character, which means beginning of string, or eliminate the second part of the range, which means the end of the string. So this basically says 0 up to but not including 2, not including 2, so that's MO. And this one says 8 through the end, which means thon. And then you can eliminate them both, and so it means the whole thing. Why you want to do this, I don't know. I just say it's syntactically there just for completeness. So up next, we're going to continue learning how we can manipulate strings.